Hello and welcome back. My name is Dari Olufumlayo and I'm your loyal mentor. In this video, we'll be exploring the /run directory. The run directory is the mount point for temp-fs file system in the computer's memory. Temporary data used by processes are kept there. But before we dig into the run directory in detail, there's an important concept I'd like to clarify, which is to understand the basic difference between a RAM, random access memory, and a hard disk, which is sometimes called storage device or hard drives. If you're completely new to the world of technology, this is one of the ABCs you really need to get out of the way. So let's get straight into it. The RAM and hard disk are both used for data storage, and the OS uses both for read and write operations, sometimes referred to as input, output, or for short, I/O. The access method to either reading or writing data is what makes them different. Now, let's talk about the RAM. With the RAM, or mostly called just memory, data can be stored or retrieved randomly. That's why it's called random access memory. It is a lot faster, and computer programs perform much better and faster from reading and writing data to the RAM. The caveat to random storage is that it is volatile, meaning data gets flushed out or deleted once the system is rebooted, or some sort of refresh is done to the process using the RAM. Also, it is much more expensive than its counterparts, which is the hard disk. So let's talk about the hard disk then. Hard disks, on the other hand, stores data in a sequential manner. Programs will have to make a long trip to the storage device to store or retrieve the data. Because it's sequential, it has to go through a sequence to reach the actual data it's interested in, which makes it an expensive operation. The good thing here is data can be stored for a very long time, even after there is a reboot to the computer. So now that this understanding is out of the way, just before we start exploring the /run directory, let's get a little more familiar with both RAM and hard disk on the Linux terminal. For this, we'll get to see two new commands in this video, which are the df and free command. So without further ado, let's get on the terminal. The first one I'd like to introduce is the df command. df. So let me bring up our text where we store our new commands, and I would write df, which means disk free, and this is used to find out information about the free space on the disk, and this relates to the storage that I'm talking about. So I'll clear my screen and type in and enter df. As you can see, it's giving us information about the /dev, /run, root, and a few other directories that we've been talking about. And on the file system side, you can see a number of things which may not be familiar to you, but on this side it's actually referring to the storage device. Okay, and to access a storage device, or to be able to store something in a storage device, you need to be able to mount it on some directory, which is what we're seeing here on the right hand side. A better way to look at this is using the df command with a flag, and that flag is -h, and the h means human readable. Let's clear the screen and hit enter. This time you can see it's giving us back in a very much more readable format, in the sense you can see 55M, unlike when we had just df that is just showing us in blocks. You can see here it's showing us in size, and the df without the flag is showing us in blocks, and you know, it doesn't really make much sense looking at the blocks bunch of numbers, but here you can easily tell 55 megabytes, 94 megabytes, and all that. Okay, so running the df -h again. Now you can have a look at, let's say, this one. Now we'll go into partitions in a different video, so don't worry too much about what's going on here. I just want to show you a couple of information about the storage device here. So this is the size, this is the used, available, and used in terms of percentage. Now, talking about the RAM, the memory, there's a command which we would introduce, which is free, and let's create the screen. Free tells us about the memory. You can see here memory. Ignore the swap. We'll talk about swap in future videos as well. But this memory is also telling us, similar to what the disk was showing us, used, free, shared, available, and all that. Just like the df command, we can also use the -h flag to give us in a much more human readable format. As you can see here, we have a total of 1.4 GB of memory, and available is 55 MB and used is 744. Now let's quickly write out our new command, free, and the flags df-h, free-h. Okay, now you might start wondering, where exactly are you going with this, Dari? Well, where I'm going is that, looking back into our run folder, let's bring back the tree command. The /run directory is actually new because I'm on a 20.04 Ubuntu. Previously, we used to have a var run, and it's still there. So let's have a quick look. ls var run. So it's still there, and if I did just run, you would see it's literally the same thing. Now there's a reason why var run used to be what was there before just the /run was introduced. It looks like the whole Linux open source community and the developers are working towards standardizing a couple of things, but that's a different discussion entirely. So the /run directory is the runtime location for programs running either in the foreground or background. These programs running in the foreground or background are what we call processes, and we'll go really deep into what processes are in the future. But for now, just know that within the /run directory, the OS keeps temporary data used by these processes. Always remember that in Linux, everything is about files and directories, and for every process running on the system, there are files associated with it. Therefore, temporary data relating to such processes are kept in memory, which is then mounted on the run directory. Let's take a quick look at that. The process files are, by the way, stored with an extension of .pid. So with this command, the star means list out all the files that end with .pid. Oops, I did put run, so we're trying to check this within the run directory. As you can see here, there are 3 processes with temp data stored with the .pid extension in the run directory. Now, another very important thing I want to show you, which is why I introduced the whole concept around RAM and disk the other time. Now let's do a df-h again. I want you to observe something right here. Tempfs is showing up in the df command as if it's a file system on a hard disk, but actually it's not on the hard disk. It's a temporary file system in memory, which is then mounted on the run directory. And what that means is the data that gets stored there, it's not permanent. A random access memory stores data that can be thrown away. For example, if you reboot the system, everything is gone. Unlike on the storage device, where even though you reboot the system, you can always find your data where you store them. Now, another important command I would like to introduce you to is the id command. So let's take a note of that. id. Alright, now id is a command that you can use to give you a couple more information about the logged in user. So you know I'm logged in as Dare, and if I do id, it shows the unique ID for Dare, and the unique ID for Dare is 1000. Now let's look into the run directory and see what we can find there. Run. This is the folder I'm interested in. User. As you can see, there is 1000, and what that means is the Linux operating system is also storing some data about every user that is logged in. If we go into the 1000, you can see there are a bunch of folders and files that relates to this user. So every time I run processes under my user ID, the operating system stores such data in the run directory. And don't forget, the data is temporary. And one more thing I'd like to quickly show you within the run folder is another folder there, which is the /run/sudo folder. Now if we did an ls on that, you can see it's permission denied. Now sudo is the command we use in Linux to run commands as an elevated user. So if I wanted to access a directory that I normally wouldn't have access to, if I had access to run sudo, I'd be able to then run that command with my ID, with my user account, as if I'm an elevated user. Now the operating system keeps information about the sudo also within the run folder. And as you can see, I don't even have permission to see what's in there except I use the sudo itself. So if I do sudo ls on run sudo, it needs my password. As you can see, it has just one file in there, and let's see what's even inside the file. And this time around I'm going to use the cat command. Oh, actually it's a folder, so let's do an ls on there and let's see what's in there. Guess what? It's showing us something about Dare. Okay, let's do an ls with more information to know if this is actually a file or a directory. It's indeed a file. Now let's see what's inside that file. Oh no, we need to do it on Dare. But guess what? It looks like a binary file. We can't even see what's inside, but essentially you can see that in Linux everything is about folders and files. The Linux operating system, the kernel, creates folders, creates files to store information just so that it can run properly. Alright, I'm gonna end this video here, and if you haven't subscribed to this channel where we produce all sorts of content relating to DevOps mentorship, please subscribe, and if you'd like to hear about the latest updates, please click on the notification bell. I'll see you in the next video.